Alright, boys and girls, welcome back to the drive-thru. Special shout out to Maddie and Kristen. Leora's also in the table. Some of my fave students. Alright, so there's a lot to this, so I'm going to get going. And not exactly going to do everything they're asking me to do, but I encourage you, if you want to, read through and kind of do it on your own. It says, begin by listing the systems of equalities you've written for startup costs. So here's our cost. We're going to change color for each one. Our cost equation was $32 per cat, $80 per dog, and we have no more than $1,280 to spend on this business venture. Okay? It also says to write your space constraint. Well, it's $6 square feet per cat. It's 24 square feet per dog, and we have no more than 360 square feet to work with. Okay? Now it says find at least 5 combinations of cats and dogs that would satisfy both the constraints represented by the system of equations. How do you know they work? Well, we'd have to guess and check, and I don't have time on this video to guess and check, but I encourage you to do that. Okay? And then it says find 5 combinations of cats and dogs that would satisfy one constraint but not the other. Well, I'm just going to go straight to Desmos for this. So here we have Desmos pulled up. I'm going to type in 32x plus 80y. Down here is where my less than or equal to is, 1280. There it shades it for us, and I wish I could change the color on that, but I can't, I don't think. Let's see. Let me pause this real quick. Okay, so I'm sure you guys are smarter than me and you can figure it out, but for right now I've just got to list. So unfortunately our cost equation is going to be shaded in red. Okay, now let's type in our space equation, and it's actually in blue, so that happened to just work out for us. It is 6x plus 24y. 6x plus 24y is less than or equal to 360. Okay, so I'm going to blow this up a little bit. So if they wanted points that worked, I don't know how to, if they wanted points that worked for one equation but not the other, you'd have to pick points here. So I'll just use my mouse. You'd have to pick points in this blue. These regions satisfy the blue equation but not the red one. These points satisfy the red equation but not the blue one, and the purple are satisfying all of them. Okay? So, shade the region of the coordinate grid that represents the solution system. Okay, explain how you found the region to shade. I used Desmos, and it's the region that overlaps them both. Keeping in mind that there are no negative options in this problem. The domain would be strictly positive. So, let's go back now to the worksheet. Rewrite your systems of inequality to include the additional constraints for feeding time and pampering time. So remember, this is just from the previous lessons. So feeding time, our constraints, was 12x, so 12 minutes per cat, and 20 minutes per dog, and that has to be less than or equal to 8 hours, which was 480 minutes per day. Okay? So let's add that to our Desmos group. $12x. Oh, look, it's green. Lucky us. Plus 20y. And that has to be less than or equal to 480. All right. All right. All right, so we got one more to do, and that is our pampering constraint. Okay? And our pampering constraint was 16x plus 20y has to be less than or equal to 480. Okay? So we go back to Desmos, add another equation, 16x plus 20y less than or equal to 480. So now you see we have 4 lines. They're all shaded. Let's grab these, move them over to our document. So I'm going to grab from here all the way over to here. Let me do this again. Let's get our That's good enough. So there's a nice look. So notice, we have a lot of different constraints here, but our answer to how many dogs and cats that we have lies in this region, the one that satisfies all of the constraints. Okay, and that's called our region of feasibility, or our feasibility polygon. You'll get into that next year a little more. All right, let me make sure we've done everything here. Find at least 5 combinations of cats and dogs that would satisfy all of the constraints. So how about 15 cats and 10 dogs? 15 cats and 10 dogs. That seems like a fair business plan. How about 25 cats and 3 dogs? I don't like that, but it might make some money for us. How about 1 cat and 14 dogs? That's what I'm talking about. How about 5 cats and 12 dogs? And finally, how about 0 cats and 15 dogs? All of those would work because they are in all of the constraint. Find at least 5 combinations of cats and dogs that would satisfy some of the constraints, but not all of them. Well, I mean, we could have one here, 0, 20. We could have one there. We could have one there. We could have one there. There's lots of these answers. So hopefully you understand that all of those pink dots represent points that satisfy some but not all of the requirements. Okay, I think we've done number 8. We've talked about number 9 as the feasible region. Okay, so the difference between 8 and 9 is that 9, I guess I already stated this, 9 only takes into account the feasible problems. The domain is taken into account, meaning we can't have negative cats and dogs. So that's what they're asking for you to consider there, is to consider the domain. And hopefully you're starting to really feel good about these inequalities and how powerful Desmos can be. If you've got a TI-84 color, you can do all of this on your graphing calculator. I'd love to show you how to do it. Another great day here in the lab. Boom!